Okay, I don't know, is the video working? Probably, probably not. Anyway, welcome back to another maths video with world's sexiest maths teacher, Mr. Daniel here. Today I'm going to show you how to differentiate inverse trigonometric functions. Now, it may seem difficult, but it's actually quite simple and you can prove them very easily using your standard trig identities. These are Pythagorean identities, meaning you can prove them on the unit circle with a radial line at around 45 degrees. So first one, tan squared x equals secant squared x minus 1. If the radial line here is 1, using Pythagoras on this right angle triangle here, we've got the line of secant there and the line of 1 there. So therefore, if we're finding this line, which is tangent, tangent is just equal to that. Does that make sense? My thing's coming undone again. There we go. Okay, and this other Pythagorean identity, which is actually a lot more simple, you've got sine, cosine, and the hypotenuse line there. If I drop the cosine down, then you get a right angle triangle. Just use Pythagoras to work that out. So we've got these identities here, and I'm going to give you a function of arctan y equals arctan x. Now that may look quite complicated, but all this is saying is this is the same as tan to the minus 1x, which is just the inverse, you know. So y equals arctan x, therefore using logic, because it's the inverse, x equals tan y. Does that make sense, guys? So if x equals tan y, if I differentiate that, it will actually be dx over dy, because it's the other way around, equals secant squared x. So the derivative of tan is secant squared. It's something you just have to know, unfortunately. So I'm just checking if I actually pressed play, because you know I forget doing that sometimes. So yeah, so I've got secant squared x here, and if I look at this again, well, I've got secant squared there, I've got tan squared there. I can do something with that. So if the derivative of arctan x should be equal to, well, first of all I need to find this in terms of dy over dx, because dx over dy doesn't really work. So if I'm going to find the reciprocal of it, basically, because it's the best way, well, it's the only way I could do it, because it needs to be dy over dx, not dx over dy. So to find the reciprocal, I just flip everything upside down. So dy over dx equals 1 over secant squared x. Oh, my board's falling over. Is that all good, guys? Can you even see that? I think you can see that. I don't know. Anyway, 1 over secant squared x, well, I can simplify that a little bit using this identity here. If I rearrange to find secant, well, actually, to be fair, I know that x equals tan y, so that's x squared, actually, x squared there, secant squared x there, rearrange, x squared minus 1, so that will be equal to 1 over x squared minus 1. Yeah, yeah, actually x squared plus 1, what am I saying? It is almost 2 in the morning, so my brain's a bit slow, but there you have the derivative of arctangent, 1 over x squared plus 1.